Hello and welcome to day number 8 of the 2024 Advent of Code. Let's jump straight into this one. We're going to be using Python. And the task today is we're given a map that looks like this, that has a bunch of antennas on them. So first of all, let's have a look at this example. So we've got these antennas, and when two antennas are in a row, they'll make two antinodes. And it describes here sort of how the antinodes come about. But really all it is that if this distance here, there's going to be an antinode, so this antinode and this antinode, that same distance on either side. So it was saying like, if this distance, there's going to be one antinode here and one twice away from it. And the same here, there's going to be one here. And if we go twice that distance to there, what we're going to do is we're going to find this distance and then do one up from there, or one back from there and one forward from there. And the way we're going to do that is we're going to search through the input that they give us, collect up all the different kind of nodes of antennas, sorry. So there's all these O ones, there's these A ones. They don't interact with each other, so only these A's, so this pair, and then this pair, this one and this one, they wouldn't interact with these ones. They create all the antinodes, and then we need to count up how many antinodes there are. So over here we've got the example data that we just looked at. If I was to print that, it looks like this. And what I'm going to do is I'm going to want to keep track of the y coordinate with y increasing downwards, index y here, just by enumerating on the file. And what I'm going to do is I'm going to say go through each of the elements here, which would give us the x coordinate. If it's a dot or a new line, skip it. And if it's not a dot or a new line, it's one of these icons, so it's an A or it's something else, put that in a dictionary with that as the key. So let's do that. So we say for index x in the range of the length of this line, we're going to get the icon, which is going to be this, idxx, and we're going to say, okay, if the icon is equal to a dot, or the icon is equal to a new line character, we're just going to continue. We could enumerate here and just have the icon directly. It wouldn't matter either way. If not, then we know that it's an icon and not a dot, and we need to store it. So we could get a dictionary. We could call it something like nodes. And this is going to be icons to a list of coords. We could say if the icon is not already in this node's key set, then add it. So icons, we'll make this in nodes icon, make that equal to a list with the first element being this coordinate, so x and y. Else, so if it is already in the node keys, we know that it's already, say we're now here because we've already added this one. We just want to add to it, so we would say append, and we would just append that tuple like that. And I think what would be helpful is if we had the height and width of the map width and map height, and this will be helpful later when we're determining if there is an antinode, say between this one and this one, it's going to be off the page and we don't want to count that, and so having these values is going to help us figure that out. And one way that we can do that is we could say on the line, each time we're going through the line, it'll be calculating it every time, but I can't think of a a smarter way to do this. If you have any ideas, please let me know in the comments. The length of the line, since they're all the same length, is the width. And then if we have, every time we've gone through one of these y's, we're going to have gone to another row. So every time we've gone through, say, idx y is 0 here, then 1, 2, all the way down, we could just add 1 to the height each time, which would be here. So after going through all of the icons in the row, we go down 1, and then we could just add 1 to the height. And if I was to print out I think we can print a dictionary like this, and I was to print the height and the width, we'd get something like this. Oh, there's a new line character. Oh, my bad. It's the wrong way around. So we've got these O's, and there's 4 of them, and the A's, and there's 3 of them, and it's a 12 by 12. And we can see here, that's everything we have here. So now we don't need to print those. We want to say for these nodes, or for the keys in the key set, each one of these keys is going to be an icon. So here it's going to be the A or the O. I'm not sure if there's a 0. Yeah, it's a 0. So this 0 and this A. What we're going to do is we're going to get the icon coordinates, coords, which is just going to be the value in the dictionary, and we can then double index through this. So index in range the length of this, same again, but we're going to go from index +1. So we're going to take all the pairs. This is a nice way to do all the pairs without double counting. So it's going to take this one and this one, this one and this one, this one and this one, and then it'll move on to this one, this one, this one, this one, and then these two. We want to get those nodes, so let's call it node 1. So that's going to be this one, and node 2. Oops. And what we want to do is we want to find the distance in both directions. So say for, let's just pick this one, the difference in y here being 2, and the difference in x being, let's say this was 1 and this was 2, difference in y would be 2, and the difference in x would be -1. Because then we can say, okay, if we do that change in y and change in x, if we were to do that from the second one, we'd get the antinode. And if we were to do that backwards from the first one, we'd get the other antinode. And that's how I'm going to solve this. So dx is going to be the difference between the x components. And similarly, dy is going to be the difference the y components. And then I can create these antinodes. So antinode 1. Well, I'm going to create them and then check to see if they're in the map. And if they are, then I know they're correct. Antinode 1 is just going to be from node 1. So node 1, 0, and node 1, 1. And it's going to go back this distance here, because it was from x to y. So if we want to go that back, we'd take the difference away. And the same thing here, minus dy. And for antinode 2, that's going to go from node 2, and we're going to go that distance again. So the difference in x that went from 1 to 2, do that again, and the same thing for distance in y. And now we've got these two antinodes, and we want to check if, say, in map, which we're going to define in a minute, if this node's in the map, then we've got say antinodes, we could add it to that. And similarly, so this would be a set of all of them for antinode 2. And the reason we want this to be a set is that if it just so happens that there are 2 nodes and then another 2 nodes that line up in a certain way, and they have overlapping antinodes, there can only be one on that cell. So we want to have our antinodes up here, and that's just going to be a set. And all that's left is to define this in map, which is going to be really simple because we have the height and width here. So to check to see if a node is in the map, we can say if the x coordinate is greater or equal to 0, because it starts at 0, and if the same with the y coordinate, and then on the x coordinate it also has to be less than the width, and similarly the y coordinate has to be less than the height. And if this, then return true, if not, return false. So we could just do this for shorthand. And then if I was to run this, and then what we're looking for is how many of these antinodes are there. So at the end of all this, if I was to print the length of that set, let's have a look here. So I think this is in so on line 43, it says get this and get that. Index 1 and index 2, it says key error 0. Nodes. Okay, so it's not nodes. It's the. I'm not going through. We're getting the coordinates from the coordinates that are associated with that icon. So whilst these are nodes, they're actually nodes coordinates. So a little bit of a bad name there, but that should run, and we get 14. And if we were to look, the example gives us there should be 14. And so if I run that on the real data, we get 314, and oh, that's not correct. Let me just debug. Okay, so the bug is here. And that should be the y component that's less than the map height. Just a little typo there. And if I was to check that here, 273, that's the answer that we want for part 1. And then moving on to part 2, it's again really similar to part 1. It says that instead of just creating an antinode on either side, it now creates antinodes all the way down. So say in this example from the top here, it would make another antinode, so it's 2 down, 1 across. It would make another one here, and then if there was more space, it would make them all the way down. And if an antinode goes over a node, you know, for another set of icons, that's also an antinode. And it's quite easy to implement from what we have here. So if I was to say that's part 1, part 2, again, we're going to have a set of antinodes that we're going to be keeping track of, part 2. And again, we're going to be doing this, but it's going to be slightly different this time, in that we get our two differences here, and rather than just going one behind the first one and one in front of the second one, we want to go all the way back with the first one and all the way forward with the second one. And I'm sure that there are more efficient ways to do this, but what I did was I said, okay, that's like going, 1 times this, 2 times this, 3 times this, 4 times this, all the way back. And then the same here, 1 times this, 2 times this, 3 times this, with the same constant over here. And so then we just have to think, what's a sensible limit for the constants? And I decided to pick, large enough constants because we're going to keep checking to see if they're in the map. So while it wouldn't be as efficient as picking, tighter bounds for the constants, I just picked something, that I was sure would work. So if we were to say, for some constant in the range, so the max of the height and width, height, all the way up to that. So, say it was a 10 by 100, it would go all the way from minus 200 if it's 10 by 100, it would go all the way from minus 100 to 100, so there'd be 200 constants we'd be checking. And it was just saying, what if, we had one here and say like one here, and it's kind of stretched the whole size. I'm sure there's an argument for a smaller range here, but again, because we're going to check each of these nodes, if they're in the map, it doesn't matter if we check some more, because if they're not in the node, not in the map, they're not going to get checked. So the antinode would look just like this one, except instead of, and would be, adding c times this. And we're adding, it wouldn't matter if we minused it, but it's just c is going all the way from negative to positive. It would be the same if we did this. It would just look a little odd. And I'm sure this would evaluate properly, but I prefer to write brackets like this just to make it a little clearer to somebody when they're looking at this. They can tell, okay, it's multiples of this. And then if that is in the map, this antinode, then we're going to add it to antinodes part 2. And then to finish, we're going to print the length of antinodes part 2. On the example data, we should get 34, so 14 was for part 1, 34 for part 2. And yep, there are 34 here, and if I were to run it on the actual data, we get 1017, and that is the solution to part 2. So great, yeah, hopefully you enjoyed that. A little bit of a shorter one today, a little bit snappier. If you did enjoy, please leave a like, leave a comment. And if you'd like, I can start adding all these to a Git repo, to a public Git repo if people wanted to have a look. Just let me know in the comments if that would be useful. And yeah, I'll be doing a video for each one of these, like the daily puzzles, but it might not come out on the day that the actual puzzle comes out. They'll just come out as quickly as I can get them out. Great, so yeah, remember to like, comment and subscribe, and I'll see you for day 9's puzzle.